Hello, we are Team 2813, the Gearheads. I'm Kyle.
And I'm Sierra.
And welcome to our first Java training video.
So today we're going to go over some primitive data types, variables, math, methods, and then how to write to the console.
So first up, we have primitive data types. So primitive data types are the basic data types that most languages include. These include integers, which are whole number values, floating point numbers, which are anything with a decimal, true-false values, which are for conditionals and are either true or false, and characters, which just represent characters in text. So here's the complete list of primitive data types. In byte, short, int, and long are all integer data types of differing sizes, which are listed on this table. Float and double are both floating point numbers, so they can store decimals, and they are of different sizes as well. Boolean is the true or false primitive data type, and char is the data type that stores characters.
Yep, so now we're going to go over some how to do variables. So you might recall variables are what you use in math, and you can store value or like information in variables. So first of all, to declare a variable, you first put the type of variable, and then the variable name. So declaration is basically like creating the variable itself. And then you're going to initialize the variable, meaning putting its first value into the variable. So you're going to do the name and then equals and then whatever the value is. And then putting it all together, you can do it all in one line, which is you do your type and your variable and then equals your value. So some examples are, let's say we're defining a variable called price and it has decimals. So we use double and then we do price because that's the name, and then equals the value of the variable. And you also, for floats, which are kind of similar to doubles, you actually have to put an F at the end to say that it's a float. Another example is for characters. So you put the character, character because that's the variable type, the name of that variable, and then you put the character, and then you use singular quotation marks. So variables actually do have some naming conventions. So first of all, variables cannot have any white space in between. So for example, you can't have this little space in between gear and heads. And another thing is variables can contain only letters, numbers, and some other characters. And the name of variable cannot be a keyword or like something that Java itself uses. For example, like class or int or something like that. So another thing is you want to name your variables with something called camel case. So camel case is basically like you see here, where the first letter of the first word will be lowercase, and then the second letter, the first letter of the second word will be uppercase. So for example, camel space case would just be camel lowercase, and then uppercase case. And yeah, another thing for variables is that for constants, you would name it in all caps. So in order to do a space for constants, you would just put an underscore. So for example, if you wanted to do gearheads like this, for a constant, it would become gearheads like that. Okay, so a cool thing about programming and Java is that you can do math with it. So for example, you can multiply, divide, add, subtract, like you can see here with the asterisk for multiply, slash for divide, plus sign for add, and negative sign for subtract. And there's also another cool thing called the modulus, which you can see here with the percent sign. And that's basically giving you the remainder of a division. So for example, if A is equal to 5 and B is equal to 2, then you would get 1 because the remainder of 5 divided by 2 is 1. And yeah. And another thing about math in programming is that the results depend, or the type of the result depends on the type that you're performing the operation on. So for example, if you divide an integer by an integer, it becomes an integer. And a thing about dividing integers is that it'll actually cut off whatever is behind the decimal point. So for example, 5 divided by 2 is usually 2.5 in actual math. But in programming, it'll become just 2 because the 0.5 will go away because it's an integer. Another thing is if you divide an integer by a float. So in this case, it would actually become 2.5 because float is a number that can have decimals. And since integer divided by float will become a float, you can actually do 2.5 instead of just 2. Similarly, with doubles, you can do that as well. And yeah, if you add an integer to a double, or a float, it will become a double or a float. So it can actually still have decimals because the type that it comes out as is able to have decimals. And another thing about math in programming, just like math in real life, is that it does follow order of operations. So so for in this case, you would do 5 divided by 2 first, which, like we said earlier, would equal 2, and then you would add it to 2.0, which becomes 4.0. And one more thing is that programmers are lazy and we want to do everything fast and efficient. So we do have something called shorthands. So shorthands are basically like a faster way to perform math operations. For example, if you wanted to add A to B, instead of doing A equals A plus B, you would just do A plus equals B. And same thing for subtracting here, and multiplying here, dividing here, and using the modulus on there. And another thing is you can increment and decrement by 1 by just doing plus plus or minus minus. So incrementing is just adding 1 to something, and decrementing is subtracting 1.
Next up, we have methods. So there are 5 main parts of a method declaration: modifiers, return type, name, parameters, and a body. Here's an example. In between these curly braces, we have the method body. This is where you put code, like setting variables and other stuff like that. Next, you have the parameters. So we have a list of parameters here. It's the type, and then the name of the parameter, which you can access inside the code body. And then if you have multiple, then they would be comma separated, like there. You can also put none and just put these parentheses and nothing in between them. So string and then these brackets is actually a type. We're going to talk about what that actually means later. You also need to have a return type, like right here. And also the method name. So here the method name is main. So yeah, the return type void here means it returns nothing. And you have modifiers like static, which we'll talk about later, but public is a visibility modifier. Public makes any code be able to call it. There's other ones like private and protected. So methods, calling. Calling a method will make all the code in the body of the method you're calling run with the parameters you pass in. In order to call a method, you put the name, parentheses, and the parameters, which are also comma separated. For example, if you want to call a method with this definition, you would just get some number. For example, here we do a variable declaration, set equal to number, and then we call the method, the name of the method, parentheses, the comma separated parameters, and then a semicolon, because most things in Java end with a semicolon, the exceptions being code blocks and some other things. You can also just put in a number here. This this underscore is actually legal with Java. You can just put underscores in number literals. This applies to both integer literals and float literals, and it's very good for separating up the number so that's easier to look at. So this is equivalent to this. You can just put in a number or any expression that results in the right data type. So the return statement. Usually you want different code to be able to communicate with each other and not just, do isolated things. So the way you do this is return types. So void isn't the only return type. You can also use like int or any other data type. And if you want to actually return something, you need to use the return statement. You put return followed by some expression that evaluates to the right return type. And when the method finishes executing, the method that called it will result, when you call it, will result in the value that returned. For example, here, when you plug in 5 to this, you'll end up doing 5 divided by 2, which is 2, plus 2, which is 4, times 2, which is 8. So this will return the integer 8. So then the result of this will become 8, which here we just set into val. You can also use return in methods that have a void return or don't return anything. You just put return and then a semicolon. If you have a method that does have a return type like int or anything other than void, you must put a return statement, and it must always return. In methods that return nothing, you do not need to put a return statement. If you have any code after a return statement, it will not get called. The method will end execution immediately when a return statement is called. For example, this line of code right here will never run because it returns before. And Java will actually issue an error if you have code that is impossible to reach. So, the main method. When the Java Virtual Machine, or JVM, tries to run a program, it will search for something called the main method. It has the declaration public static void main with string and then these 2 brackets args, and then the body is just the stuff that will run when your Java program is started. So, yeah,
Okay, so now putting it all together, first of all, how do you print to the console? So the line of code that you need to print to the console is basically system.out.println, which you can also use system.out.print to replace depending on what you want to do. So if you want to print something and then go to the next line and print something else, then you would do print ln. But then if you want to print something and then have something directly after it, you would do system.out.print instead. Okay, so now it is your turn to do exercises and practice this stuff that you learned today. So for your project today, you're going to try to calculate and print the first 5 numbers of any sequence in Java. So you can choose a sequence, but here are some examples that we came up with. So for example, the Fibonacci sequence is a sequence where you start with 0 and 1, and then each next number is the previous 2 numbers added together. So for example, 0 plus 1 is 1, which makes a third number, and then 1 plus 1 is 2, which makes the 4th number. And another sequence that we came up with was the factorial sequence. So this one basically multiplies the number by all the positive integers below it, basically less than it. So for example, the first part of the factorial sequence, 1, will just be 1 times nothing, which is 1. Second part would be 2 times 1, which is 2. And the third part would be 3 times 2 times 1, which will equal 6, and so on and so on.
So we're going to give you some time to actually work this out for yourself. You can pause the video if you want to work on it.
Okay, so for the Fibonacci sequence, we have 3 variables, n1, n0, and tmp.
First, we need to set n1 equal to 0, and then we need to set n0 equal to 1.
The temporary value, tmp, we set that equal to n0. And n0 is currently 1, so now this contains 1. So the first thing we do is we take n1, which is currently 0, and add it to n0. 0 plus 1 is 1, and we store it into n0. So this 0 plus 1 is 1, which we store in here, which is 1. And then we take the temporary value and put it into n1. So since that's 1, this becomes 1. And then we print out n0, which is currently 1, so the output is now 1. And then the next thing we do, we set the temporary value equal to n0, which is 1. This will now contain 1 instead of that. And then we take n1 and then add that to n0, which will become 2, and set that to n0. So this will become 2. And then we set n1 equal to temp, so this will become 1. And then we output n0, which is now 2. Then we take temporary value, set it equal to n0, so this will become 2. Add n0 and n1, which becomes 3. And then we sort into here. Then we set the temporary value, n1 equal to temporary value, which is this. Then print out n0, which becomes 3. Then we keep on repeating the same thing. Set this equal to this. Add these 2 stored into here. Set that equal to that. And then this goes to the output, which is now 5. And then for the last one, we set this equal to n0. So that was 5. Add 3 and 5, that will become 8. Set this to that, then we print out 8. And that is what the code will do.
Okay, so now we're going to take a look at the factorial sequence. So in this code, you have your variable n and your variable last, and you're going to set n to 0. And next, you're going to set last to 1, and then it tells you to increment n by 1. So we're going to plus 1 to 0, which is 1, and then it tells you to multiply last by n, which will become 1 times 1, which is 1. And then you're going to output your last, which is also 1, and then you're going to do that again. So we're going to add 1 to n, which is 2, and then you're going to multiply 2 times 1, which will become 2, and then you're going to output your number, which is 2. And then do that again. You're going to increase this by 1, multiply these 2 together, which will become 6, and then you just output your last again. We do that again, increment by 1, multiply them together, which is 24, output last, and then we're going to do that one last time. So increment this by 1, which is 5, multiply 5 by 24, you're going to get 120, and then you're going to output 120. And yeah.
Thank you for tuning in to our Java class. Hope to see you in the next video, and make sure to have a great evening, morning, or whatever time it is in your current time.
Bye.
Bye.